Here we go. We have a question missing in array. So you have given an array of size n minus 1 that contains distinct integer in the range of 1 to n. Inclusive means n is also included. We need to find the missing element. So the array is a permutation of size n with one element missing. We need to return that particular missing element. In this case, we have n is equal to 5. So we must have a missing number between the range of 1 to n, 1 to 5 in this case. So the missing number is 4. So that's about it. Let's build the approach. So there are many approaches for this particular problem. I will tell you three popular approaches. So first is XOR. XOR means if we have a similar thing, so it will give us 0. So if we have a similar thing, it will give us 0, or if we have a different thing, it will give us 1. So the similar thing is important in this case. So suppose we have 1, let's take 5. So 5 is written like this. If we again take 5 and XOR it, so it will give us 0. So that's the important thing here. We have these elements. So I will maintain a variable x. First I will take XOR of all these elements 1, 2, 5 and 3. It will give us something, but this is not important. We have number from 1 to n. In this case n is 5. So I will again run a for loop and take every index. In this iteration I will not taking an element, I am taking index from 1 to n and take XOR. So 1 XOR with 2, 2 XOR with 3, 3 XOR with 4, 4 XOR with 5. So these similar thing will cancel out each other. So 1 will cancel out 1, 2 with 2, 3 with 3, 4, 5, 5 with 5. So the only remaining element is 4. So at the end we have the missing element, which means we have only one element. We have only one element that is not cancel out with this similar element. So that's about it. Let's build the first approach. So let's code this. We have a variable x. First let's take the XOR with every element, and in the next iteration let's take with every index from range 1 to n. So take XOR with I, and at the end we have our resultant. So let's submit this. The time complexity in this case is order of n and space is constant, which is the expected space and time complexity. So that's about the first approach. Let's build the second approach. In this case we know the range. So the range is 1 to 5. So let's take this similar example. 1, 2, 5 and 3. We have a range of 1 to 5. So let's sum this. So 1 plus 2 plus 3 plus 4 plus 5. Instead of this, what we can do? N plus n by 2 and multiply n plus 1 by 2. So now subtract every single element. Minus 1, minus 2, minus 3, minus 5. So it will cancel out this element, this and this. At the end we have an element which is the single element in the array. So that's about the second approach. Let's code this. We have a summation of all the element in the range of 1 to n using this formula. Then we need to subtract every single element. At the end we have our resultant. So let's submit this. In this case the time complexity is order of n and space is constant. So that's about the second approach. So let's wait for it to submit. This solution will also work. Let's talk about the most interesting approach for this particular question. We know that the elements are in the range of 1 to n. So this is important. And in this approach, I will tell you the cyclic sort. So in this approach, the cyclic sort will modify the input array, which is not recommended. But still, for learning purpose, let me tell you the approach. So we have 1, 2, 3, 5 elements. 1, 2, 3, 5. So let me modify this 3, 2, 5, 1. And we have index. In the ideal case, we have a element 1, 2, 3 and 4. So 0, 1, 2 and 3. So what it means is we have a range of 1 to 5 and we have values 1, 2, 3, 4. So the missing value is 5. So the element is index plus 1. So we need to somehow sort this array. So this element will move to somewhere, and all these elements except except the nth element, because the last slot is for n minus 1. If the element is n, we cannot shift it to anywhere. So first we have this. So this element, the three element is have to be placed in this index. So first we have index I is equal to 0, and we have its correct index. Correct index means the element minus 1, element is 3, 3 minus 1 is 2. So this particular element is have to be here. So we will swap the elements. So 0, 1, 2 and 3. So we swap the elements. After swapping the elements, we have this. So we have this element. So this particular element, we are still on index 0. So this particular element is 5. So the 5 element have to be on fourth index, but fourth index is not valid. So its correct index is 4, but fourth index is not valid because the element is n. We have range of 1 to n. The element is n. So that's why we skip this element and will go to the next element. In this case, our I is 1, our I index is 1, and element and its correct index. So 2 minus 1 is 1. 2 minus 1 is 1. So this particular element is where it's supposed to be. So we does not need to change or modify its value or swap the index. So let's move to next index. So the I, in this case, I is 2 and this particular element is 3. So 3 minus 1, 3 minus 1 is 2. So this element is supposed to be here. So its index is correct. Next we have this. So this particular index is 3 and its correct index is I minus 1, which is 0. So this particular element supposed to be on first index. So we need to swap the values. So 1 here and 5 here. Now this element, we have this element. So our I is 3 and our correct index is 4. But we have this particular element as nth element and fourth index is inaccessible. So we just move to next index. Now we have index out of bound. So we just get out of the while loop. So now we need to check, is the particular element, is this the correct index or not? In this case, it is correct, means index plus 1 is the element, this is correct. Index plus 1 is the element, this is correct. Index plus 1 is the element, this is correct. Index plus 1 is the element. In this case, it is not correct. The element, the correct element is 4, but the element is 5. So our missing element is 4. So we need to return I plus 1. If our index is like this, so in this case, our nth element is missing. So we need to return n. So let's code this. First we have I 0, while I is less than the last index. So we need to find the index. We need to find its correct index. If the value is inside n, means the value is from 1 to n minus 1 and the element is not in its correct position, then we need to swap the elements, element I and element correct. So this is the if condition. Else, in the else condition, means the element is correct index, or this is the nth element, so we just need to move to next index, so I plus 1. After this we are outside the while loop, so we just need to check the elements and indexes. So if the element and index is incorrect, the element is not in its correct position, so we need to return the missing element, or we have all the elements between I to n minus 1, so nth element is missing, we need to return n. Let's give it a try, and all three solution is given in the description box. If you guys have any doubt, feel free to ask in the comment section. Give this video a thumbs up to motivate me, and subscribe to this channel. Thank you all for watching.